Astronomers have finally confirmed the existence of the second exoplanet, which was discovered by the Kepler Space Telescope. It is the Neptune-sized KOI-5b, which was first discovered and flagged as a potential planet by NASA's pioneering Kepler Space Telescope in 2009. It has been referred to as an elusive alien world, and it was the second candidate ever identified by Kepler, which hunted for planets on two different missions from 2009 through to 2018. Kepler used the transit method, spotting the telltale brightness dips caused when alien worlds crossed their host stars' faces from the spacecraft's perspective. This research was incredibly productive. Nearly two-thirds of the roughly 4,300 known exoplanets were discovered by the Kepler Space Telescope, and the analysis of the telescope's huge dataset continues to return new discoveries. KOI-5b slipped through the cracks more than 10 years ago, partly as a result of that data deluge. The Kepler team spotted an apparent transit signal belonging to a roughly Neptune-sized planet that whipped around a sun-like star every 5 Earth days. This star and the apparent planet lie about 1,800 light-years from Earth in the Cygnus constellation. Further investigations revealed that the parent star had a companion star, making analysis considerably more difficult, and there were many other candidates to check out as well. So at this time, KOI-5b was quickly abandoned, mostly because it was just too complicated. According to NASA's chief scientist of Exoplanet Science Institute, which is located at the Infrared Processing and Analysis Center at the California Institute of Technology in Pasadena, during a media interview on January 11th at the 237th meeting of the American Astronomical Society. Indeed, KOI-5b has been more complicated than researchers realized at the time. By 2014, CRD and other scientists had determined that the KOI-5 system actually harbors 3 stars, and it still wasn't clear if KOI-5b actually existed, or if the 2009 signal was generated by one of the companion stars. KOI-5b came back into the spotlight as a result of Kepler's successor, NASA's Transiting Exoplanet Survey Satellite, or TESS, which was launched in 2018. TESS also spotted a signal in the KOI-5 system, which was generated by a potential planet with an orbital period of 5 Earth days. Of course, at that moment, the research team remembered the original target, so they took it seriously and they took all the information on the system, the transit observations from Kepler and TESS, as well as radial velocity data gathered by ground-based instruments such as the Keck Observatory in Hawaii. Radio velocity instruments and measurements quantify how much an orbiting planet tugs on its parent star gravitationally. Such work can reveal the approximate mass of an exoplanet, whereas transit observations give a rough idea of its size. Taken together, the data confirm that KO-5b is indeed a planet, so that's about half a massive planet as that of Saturn. The new research, which CRD detailed at the AS meeting on Monday, also revealed other details of the KOI-5 system. For example, the main star that KOI-5b orbits, star A, has a close companion, star B. Its duo orbits each other once every 30 Earth days. The third star in the system, star C, is much more distant, orbiting the AB pair every 400 years. In addition, KOI-5b's orbital plane is misaligned with that of star B, suggesting that the star may have given the planet a gravitational boost sometime in the system's history. Stars and their planets form from the same cloud of gas, and thus so their orbital planes generally match initially unless something occurs along the line. The KOI-5b is far from the first planet to be discovered in a multi-star system, but such systems seem to host planets less frequently than do single-star solar systems like our own. And these are reasons that are still being investigated by researchers and astronomers along with scientists. Stellar companions may partially quench the process of planet formation. They still have a lot of questions about how and when planets can form in multi-star systems and how their properties compare to planets in single-star systems by studying the KOI-5 system in more detail. Perhaps, as scientists, they can gain further insight into how the universe creates its planets. Of course, like, comment, share, and subscribe. Let me know what you think about this fascinating discovery that has been made by astronomers in relation to the confirmation of KOI-5ab exoplanet, which is orbiting a multi-star system. There are at least 3 stars within this KOI-5 system, with only 1 planet. This is quite fascinating. Thanks for watching, and remember to be safe. Have a good day. Goodbye.